Welcome. In this short video, I will explain to you how trig sub works. In particular, I'm going to cover 3 questions. When shall we use trig sub? Which trig function shall we use? And how to find the proper balance after the substitution. Well, the answer to the first question is, we use trig sub when the easier methods do not work, and the integrand is related to 1 plus x squared or 1 minus x squared. Note that the constant here does not matter. It can be 1, it can be 5, it can be 10, and there can also be a coefficient in front of the x squared term. As you'll see later, these changes can be easily baked into the trig sub. Now let's see some examples. For example, if I want to integrate 1 plus x squared dx, well, obviously, easier method works here. So you don't need to use trig sub. But if I want to integrate square root of 1 plus x squared dx, then inspection does not work, and we have to use trig sub. Okay, or we can also integrate square root of 1 minus x squared dx by trig sub. Or 1 over 1 plus x squared dx and 1 over 1 minus x squared dx, or 1 over square root of 1 plus x squared dx, or 1 over square root of 1 minus x squared dx. You get the idea. We can all use trig sub here. Okay. Now, sometimes you see this integral of x times square root of 1 plus x squared dx. Okay, and you see, okay, this guy seems more complicated than this guy. Okay, however, easier method actually works for this one. In particular, we can use the U substitution, where u is equal to x squared plus 1, so du is equal to 2x dx. Okay, that will simplify our life a lot. So this is our answer for when shall we use trig sub. Now let's come back to our question number 2. Which trig function shall we use? Well, the answer is it depends. It depends, but Pythagorean theorem is your friend. Let's say I want to integrate dx over x squared plus 1. Now, hopefully this x squared plus 1 reminds you of Pythagorean theorem, which says if I have a right triangle like this, and the length of the 2 sides are a and b, and the length of the hypotenuse is c, then Pythagorean says a squared plus b squared is equal to c squared. The goal here is to bake x squared plus 1 into this right triangle. You can probably see that if I make the 2 sides to be x on 1, then the hypotenuse will just be square root of x squared plus 1. And then obviously x squared plus 1 is just the square of the square root of x squared plus 1. Okay. I would also call this angle theta for our trig substitution. Now, you can already see that x squared plus 1 can be related to a trig function of theta. We also need to write dx as a trig function of theta and d theta. The way to do that is to first find the simplest connection between x and theta. The simplest connection I can see here is tangent theta is equal to x. Okay, because tangent theta is equal to x over 1. Now, in order to get dx in terms of d theta, we're going to differentiate it. you can think of it as x to be a function of theta, and then we differentiate both sides with respect to theta. So on the left, we have secant squared theta. On the right, we have dx by d theta. And then we can multiply d theta on both sides. Then we have secant squared theta d theta equal to dx. Okay. Now, basically, we can write dx as secant squared theta d theta. And then from the right triangle, we also see that secant theta is equal to square root of x squared plus 1, which means that secant squared theta is equal to x squared plus 1. So basically, we can replace x squared plus 1 by secant squared theta. Okay, now we can do that. Equal to integral, well, dx is equal to secant squared theta d theta. And then x squared plus 1 is equal to secant squared theta. So secant squared theta and secant squared theta will cancel out. This guy is equal to integral of d theta, which is just theta. Fantastic. But we also need to write theta back to x. Okay, so we're going to make use of this connection here because we know tangent theta is equal to x. So theta is just equal to arctan of x. Let's say I want to integrate dx over square root of 1 minus x squared. We're going to start by drawing a right triangle. And then let's think about how to assign lengths to each side. Because by Pythagorean theorem, we know a squared plus b squared is equal to c squared. Now this can also be written as a squared is equal to c squared minus b squared. Which, if you look at our integrand here, basically 1 is c squared and x is b. Which means that we can put 1 on the hypotenuse, and then let's put x here and square root of 1 minus x squared here. And let's call this angle theta. Okay. And then let's also find the simplest connection between x and theta. In this case, the simplest connection would be sine theta equal to x. And then in order to find dx in terms of d theta, we're going to differentiate both sides with respect to theta. So here on the left, we have cosine theta. On the right, we have dx by d theta. And we can multiply d theta on both sides. Then we have cosine theta d theta is equal to dx. Okay. Now we can replace dx by cosine theta d theta. And then the next thing is going to try to express this one in terms of theta. Well, obviously, we see that cosine theta is equal to square root of 1 minus x squared. Good. So we can just use cosine theta as square root of 1 minus x squared. So this integral becomes integral of cosine theta d theta divided by cosine theta, which is equal to the integral of d theta, right? Because cosine theta and cosine theta can cancel out, which is equal to theta. And of course, we're going to change it back to x. How do we change it back to x? Well, we know x is just sine theta. So theta is equal to arc sine of x. Is equal to arc sine of x. Let's look at how to integrate with a different constant. Let's say it's 4 minus x squared. Well, it's really simple because in this case, you're gonna still use a right triangle. And the only difference is that your hypotenuse, instead of it being 1, this times 2. And this side is x. This side will become square root of 4 minus x squared. Let's call this angle theta. And then just like before, we're going to say sine theta is equal to this times x over 2. And so we differentiate both sides. We have cosine theta is equal to 1/2 times dx by d theta, which means cosine theta d theta is equal to 1/2 dx. And then also cosine theta is equal to 1/2 times square root of 4 minus x squared. And then we're gonna substitute into the original integral. So dx is equal to 2 times cosine theta d theta. And square root of 4 minus x squared is equal to 2 times cosine theta, which turns out to be integral of d theta, which is theta. And theta here will be equal to arc sine of x over 2. Great. The third question is how to find the proper bounds after the trig sub. Well, the answer is that you may not need to find the bounds for theta. Oftentimes, it is easier to change everything back to x and use the bounds for x. But if you want, you can also find the bounds for theta and work with theta. Let's try to reuse this example. So now I want to find the definite integral from 0 to 1 dx over x squared plus 1. What we can do is that let's first find antiderivative for this guy. So I'm going to start a new line and say, okay, integral of dx over x squared plus 1, and then do whatever we just did with the trig sub. And then at the end, show that this guy is equal to arctan of x. So the integral, the definite integral from 0 to 1, dx over x squared plus 1 can be written as arctan of x from 0 to 1, which is equal to arctan of 1 minus arctan of 0, which is equal to arctan of 1 is equal to pi over 4. Arctan of 0 is 0, so that's equal to pi over 4. And of course, you can directly work with the bounds of theta and do not change back to x. So let's say alternative. This integral from 0 to 1 dx over x squared plus 1 is equal to, we can do the same thing as we did and say, okay, dx is equal to secant square theta d theta, and x squared plus 1 is equal to secant square theta. So this guy here is equal to secant squared theta d theta divided by secant square theta. But here, you have to fill the bounds for theta, because on the left of the equation, it's a definite integral. It has the bounds for x. So basically, we're asking the question, which theta corresponds to x equal to 0, and which theta corresponds to x equal to 1? How do we know that? We can look at this equation here. If I put x equal to 0, I can solve for theta. So tangent theta equal to 0 gives me theta equal to 0. So here the lower bound for theta will be 0. And if x is equal to 1, tangent theta equal to 1 means theta is equal to pi over 4. This guy, the upper bound of theta is pi over 4. So this guy is equal to integral from 0 to pi over 4 d theta is equal to theta. It goes from 0 to pi over 4, which is equal to pi over 4 minus 0 equal to pi over 4. Okay. I hope this video helps you with trig sub. Let me know if you have any more questions.